Hello, wonderful physics students. So in this video, we are going to review the concepts that we covered in class about electric potential. And hopefully by the end of the video, you will feel more confident in these concepts and ready to tackle some problems. Okay, so the equation that we learned, or the definition rather, that we learned in class was that the change in electric potential energy from point A, there we go, from point A to point B is equal to the test charge times the change in electric potential, or change in voltage, from point A to point B. So the change in voltage from point A to point B is the change in electric potential energy for a 1 coulomb charge moving from A to B, which is equal to the work you would have to do to move it from A to B. So let's look at an example to make this a little bit more relevant. Okay, so here I am on one side, and we're going to look at this good old gravitational potential energy that we know and love very well. And we're going to contrast it with electric potential energy that is new to us. And so we have our good old parallel plates right here with equal and opposite charge distributions on the plates, and the electric field lines are drawn for us very nicely right there. Okay, so if I have a bowling ball on top of my head, luckily no one was hurt in this process, it has low gravitational potential energy. The word got cut off there, sorry about that. So it has low gravitational potential energy because it's close to my head. So likewise, if I put a little positive charge right here by the negative plate, it's as far over as it can move. It wants to get close to the negative and far away from the positive. So this has low electric potential energy. So if I get an outside force, like a hand, the hand, pulling the bowling ball or pushing the bowling ball up, or the hand, pushing the little charge object closer to this positive plate where it does not innately want to go. This bowling ball does not want to fly off my head. So we need an outside force. So this force is providing work. So the change in gravitational potential energy in this case is positive. We brought it from a low potential energy to a high potential energy. Likewise, this change in electric potential energy for this little positively charged object goes from low potential energy to high potential energy. So the change in potential energies for both objects is positive. Now if we remove the force that brought it to a higher potential energy, then what's going to happen? Well, the bowling ball falls and the charge moves back to its lower potential energy state. Where does the kinetic energy come from? So if you recall the buckets of kinetic and potential energy, if potential energy goes down, the kinetic energy bucket gets filled. The energy juice sloshes between the buckets, but the total energy remains the same. So we could write this as the change in electric potential energy. Since we're dealing with electric potential energy, we'll write it in terms of this, equals the change in kinetic energy. But wait, since the electric potential energy is going down, we put a negative in front of here because the change is going down. So, and the kinetic energy is increasing. So a negative times a negative gives us a positive, and things work out. Now, when I said the definition in the very beginning of this video, we learned it should have sounded kind of familiar. It was very similar words to when we were learning the electric field. So the electric force is equal to a test charge times the electric field. Electric potential energy is equal to a test charge times the change in electric potential. The change in electric potential energy is equal to a test charge times a change in electric potential. If the test charge is 1, we need units here, don't we? 1 coulomb. There we go. Then the force, the magnitude of the force, equals the magnitude of the electric field. And the magnitude of the electric potential energy equals the magnitude of the electric potential. All right. That's it for this video. We'll see you next time.